Welcome back, fellow Blender users, to part 4 of the motion tracking tutorial series, and like I said in the last part, we're just going to be doing some camera tracking examples in this one. So for everybody waiting for object tracking, I'm just going to make you wait a bit longer for part 5, but it is coming, and then you will know this sacred skill that you guys keep talking about. We want object tracking, it's coming, but first I have to hit you over the head again and again with how to do camera tracking, because object tracking is essentially the same thing. So this is something we need practice in. We have 2 more shots to go through. I think I actually showed them in the last part, but why not show them again? So we have this second moving shot, which I always forget to remove the audio for. So we have the second shot. It was a bit out of focus in the beginning, but when I exported this as an image sequence, I'm sure I cut it off. So this is actually an example with a very clearly defined floor and wall, which wasn't the case last time, so we'll go through an example like that. And then the next one is just the tripod shot. Again, this is also called a nodal pan, where the camera is still on a tripod, and it's just pivoting around like this. So there's no parallax you get from actually walking around, which actually makes the solving process a bit different, so we're going to talk about that. So without further ado, part 4, more camera tracking examples. Let's open up Blender. And now we're actually using... I always have to wait to say this because of the gray screen, but it's still faster than opening other 3D packages. We're using Release Candidate version 2, which is very exciting. But we need to do the things that I keep saying over and over and over again. Do you know what they are? Yes, one of them is indeed, you're right, is going into the Render tab, Color Management, and then changing Filmic over to Standard so our footage isn't graded in the Filmic tone. So we just have Standard, and then in the, haven't used Blender in a while, in the Output tab, I don't know why I even forgot that. I haven't used it in the day, so whatever. In the Output tab, we are going to change our frame rate to 30 frames per second, because that's essentially what I filmed it at. And in the Movie Clip Editor, which is where we do pretty much everything related to tracking, we're going to open up one of these image sequences. So tracking, camera track, shot 2 sequence, and then import that all in. And by the way, I'm thinking of at some point releasing all these sequences so you guys can actually use them. I'm still trying to figure out how to do that because it's a lot of data, but eventually you may have your hands on this. So set scene frames to make sure we're going from 1 to 161 so we don't have extra long timeline here. We're going to prefetch to load this into memory. You know the drill. Again, this is just review. It's kind of an intermediary tutorial episode. And for this tracking, I'm going to use, for most of this, I'm going to use the affine model to get the deformation and the shearing. And then when we do some of this brick stuff, it might be better to actually go all the way with perspective. So affine will work for this. We don't need to go all the way. Let's enable normalize to make our lighting intensities not an issue. Again, invariant to lighting intensity. And then, or lighting changes, I guess I should say. And then, let's see, in tracking settings extra, we're going to use a correlation of 0.9, which again means we need a 90% matching tolerance for it to keep tracking, otherwise it's going to stop. Again, we reviewed all of this before. And with all that said and done, let's pick a very obvious candidate for a tracker. Again, I'm looking for things that have high contrast features and that I expect will last throughout the majority of the shot with high accuracy. And this should probably do it. So Alt-S for the search box. Make sure that is nice and big enough, and let's open up our tracking menu so we can see what we're doing. We can reposition this, and then locking with L, we Control-T to track forwards. Did that last the whole shot? You bet it did. So Control-L to lock, and let's pick another. And we could pick this one next to it, but again, we're not gaining that much new information from doing that. We want to have our trackers distributed 2D, distributed a lot in this 2D space, so all around our shot, and also in 3D. So these two spots are very close 2D and 3D, so we're not actually gaining that much out of it. Instead, I feel like this is far enough that we'd actually gain something by tracking it, so let's do that. Again, the main idea of camera tracking is really the theory of which trackers you should pick in the first place. It's not how to do the actual tracking, which is something we've gone over. Okay, so this only survives 78 frames, so we're just going to lock it, and we'll see if it pops in again, because maybe we can do a joint track. It does pop in again. So let's handle that. We can add another tracker. and then Control T to track forwards. This one made it to the end, and then finding where this track started, we can go back with Alt left arrow to get a couple extra frames. Okay, let's lock that and then go back to this tracker, shift clicking it so we have both selected, and then track, join track. So now we have a single track that we can just play it. So it goes here, it cuts out, and then it comes back. If we go to the graph, it's going to be kind of hard to see if we don't isolate this from all the others, but you can see there's a gap in this highlighted one, and this is where it doesn't exist. Just a lot of review, but it's very important. And this is a good example to show you how fast you can actually do camera tracking when you're not explaining every single aspect of it in depth. So let's see, what else can we find on the floor? I like this little white dot. Let's Control T that boy. Okay, it only made it this far. Perhaps we need another reference point, so we'll just scale that down and maybe increase our search box so it doesn't leave the search box if that was the issue. Control T. Okay, that made it all the way to the end. That makes me happy. Pat on the back. What else can we do on the floor before we move on to this wall? We can try this one in the distance. I like it a lot because we have a lot of difference in this one relative to the others in terms of where it is 2D. It's all the way on the left of the screen, whereas these ones are on the center, and in 3D, it's kind of further down this alleyway. This very weird alleyway that I decided to motion track, but we'll disregard that. Control T. Okay, so that's good up till then. If you're doing this professionally, like for a client, you might want to review all these trackers, make sure they're not shifting around, but I have a good sense that that's not the case for here. And does it come back? Of course it does. So we're going to do another join track kind of deal. And I don't think we have already. Have we saved? We have not. We should probably save, just in case we have a crash. We are in release candidate 2, so hopefully it doesn't crash. We'll call this tracking for fun. That's what we're doing here. Okay, so track backwards, Shift Control T. Perfect. And after this, you guys are going to be absolute pros at camera tracking. And you don't have to thank me. You worked very hard at it. Control L. And that's a shame. It almost made it to 161, but it didn't. And that's fine. So we need this one selected, and then go back, Shift click to have both of these selected, join tracks. And then let's try to get one more on the floor before we move on here. And we don't need to just use dots, even though they're here and they're very convenient. There's no reason we can't use a more complicated pattern like this failed attempt at graffiti. We can just pick the corner of this, maybe rotate it. Or you know what, I'm going to pick something further away from the wall, like right here. Scale that up. Again, since it's affine, it's going to kind of simulate these perspective changes. And you know what, since we're doing a pattern you can really tell the perspective change on this one, I'm going to change this to perspective. So tracking settings, individual to this tracker, so not here, but here, we're going to change this over to perspective mode, and then Control T. And it's going to take a bit longer, not much longer. Let's lock that in. And you can see that this is stretching because we're moving closer to it. But again, all that matters is this center point. Does that look like it's remaining where it's supposed to be? We review over here. It should just be on the tip of this S-looking thing. Yeah, that's very good. So Control L. So at this point, we have like 5-ish trackers. Some of them are blinking in and out on the floor, and now we can focus on the wall. Now, you may think to yourself that this is a very good surface to do tracking, and it is. There's lots of detail, but the issue is it's very repetitive. So we may run into an issue where if we're tracking this right here, this intersection of lines on the bricks, that's a very good tracker. However, it may mistake it for this one because they look very similar. So there's a lot of pattern and repetition that's not necessarily good. So we need to pick something with some extra detail so it doesn't jump around and it knows which brick we're looking at. So anything that includes like a dot like this, that's unique, or maybe some color like this is going to be very easy to hold on to as opposed to just picking something randomly. So like I said, we're going to do perspective for these bricks. And let's start off with the obvious option, doing something over, we could center it here, but I don't want to get this other 3D object in here, so I'm going to go a bit higher. Scale that up so it's containing some of our, is that brown or orange? I can't tell, but we want to contain some of that. And hopefully that is unique enough so that when we hit Control T, yeah, it looks like it's grasping on there. We want to review. Ideally, you pick the center point to be like a little dot right here so you can tell if it's staying on, because here we don't really have any reference. but I do think it's a safe bet to say that this is tracking on. We're just going to go for solve errors of under 0.7, 0.6. That is our goal for all of these, because that's what you would need to do in a real environment where you're tracking shots for a movie or something. Well, I guess if you're doing it for a movie, they want like under 0.2, but we're not going to be that strict. We're going to be a very, accepting movie studio that doesn't care too much. So again, I'm looking for bricks with a lot of unique details here, like these dots, Control T. Okay, we got a lot of motion blur here, so we'll see if we can actually get this ourselves. First of all, we want to try the the automatic approach before we manually try matching this. So we're just going to add another reference frame by changing the search box, and probably won't match on, but we'll see. Oh, it did this time. And Blender is much better at seeing where this is going than I am usually, although we do have that human sense to see where it is, but I do like Blender doing the work for me. Okay, we can get some extra frames. It's over here on the margin, so we just need to scale this down a little. Can we get extra frames? Okay, 143, scale this down, Alt-right arrow. Okay, we got 144, and then I think we gotta let this one go. So just let's review this tracker since there was some motion blur issues. Does it look like it's staying on there? It does. Okay, that's a good tracker. I wish it stayed on the whole shot, but that's fine. What else can we get? Let's try to get this one right here. Scale that up. And hopefully you guys are getting very good at doing all this tracking process and what's very close to real time. I don't even know what that means. I just mean fast. Because camera tracking, unless you have a tricky shot, I haven't done any tricky shots on this tutorial series yet. Any shot that you have seen here, you should be able to track very quickly, is the point I'm trying to get across. Okay, what else can I do? I'm going to go back to the floor, try to get stuff over here in the corner, because we haven't filled that area. Even if it's only for a couple frames, we'll do an affine track on this one. Probably only going to get 30 frames out of this. 56, better than I expected. And we might be able to recover some more with joint tracking, we'll see. No, because I move the camera physically forwards, so we don't actually get back to that tracker. Okay, so that's locked, we'll leave it as is. And it might be a good strategy to go to the last frame, shift right arrow, and then see that we only have 6 active trackers currently. So let's add a tracker over here. Scale that up, and then track backwards, which again is a bit slower, but it's fine. That's Shift Control T, or you can just hit these buttons, or just hover over them and it will tell you the shortcut. So this is 1 frame backwards, and then this is all the frames? Yeah, Shift Control T. So it'll tell you the shortcuts if you ever forget. But hopefully you don't forget, because I keep saying them out loud. Not to annoy you, but just to make sure you have this in memory. I think it's important. What else? Let's get some stuff on the wall here, changing back over to perspective, so we can always change between motion models. It's really not a big deal. Pick up some of this. We can even rotate it so it goes with the bricks. It's not really going to help, but something interesting to do. Shift Control T. I expect this to be very slow because we're going backwards and doing perspective. But very soon we should have 8 active trackers throughout the whole shot, so that's good. And again, it doesn't have to be the same 8 trackers, just at any frame there has to be 8 active trackers. And those can blink in and out of existence as long as there's always a set of 8. And while this is tracking backwards, I'll just tell you about an email I got about this motion tracking series. I've gotten this comment also a lot in my videos. For the creating image sequences thing, when we go over to, the video editing workspace, put in our footage, and then export it out as an image sequence, there's nothing wrong with that, but there is a faster approach, and that is using, FFmpeg. You're doing some commands on the console. So if you want to mess around with a bit of coding, there is a faster way to convert over to image sequences. So we're adding a new reference frame here. And this will be a bit faster since we scaled things down. I can't remember if we scaled down the search area or the pattern area, but either way, there's less to go through. Less combinations means faster. I think always. Always. Okay, frame 40, going backwards, so there's only 30 or so to go through, and we can see right here that it's really staying on this dot, so this is a quality tracker. Okay, lock that in, and let's try to get one more, because how many do we have now? We do have 8, but I would like to have one more that lasts throughout the whole shot. That would make me a bit more comfortable with what we have going on here, and we can always add more trackers after trying to do a solve. Let's go for affine, put one here. And this isn't the greatest dot to use because it doesn't have that much contrast. You're going from this purplish gray to something that's a little lighter. So we can either scale this up to contain one of these dots, but that's using a lot of pattern area, so it needs to look through a lot of combinations. What I would recommend is maybe picking one of these dots that has higher contrast. But hopefully we don't lose it in motion blur. So we'll see. Okay, made it back 2 frames. See what the issue is. Does it just need a new reference frame? Might just not be a very good tracker. I'm gonna give up on this one. The motion blur is distorting it too much that it doesn't seem to pick on to this. Let's try something different. All trial and error here. I haven't tracked these shots before recording this tutorial, so hopefully we get a good solve live. So I show you the actual process I'd go through. So Shift-Control-T. So this one seems to be working a lot better. Of course, it's going to blink out of existence, but maybe it will come back. So it's the dot above this graffiti is just what I want to remember. So I can match it right here. Always important to not match it to a different dot. So you're like, oh, it came back and you put it right here. Not good at all, because then you've basically said that it moved to a different location and will interpret that as camera motion that doesn't actually exist. So we can track forwards a little. And then once we do that, we'll just go all the way back. Okay, lock that in, and then find the previous one, which is this one, shift-click, and then join tracks. And at this point, we can count them, or somebody actually said if we go to the VFX workspace, which is, I don't know where it is. Yeah, VFX motion tracking, it will actually give us a dope sheet that tells us how many trackers are active on each frame, but I'm going to assume that there are actually 8 active trackers here, and we can head over to solving. Again, I don't want to pick keyframe A and B for myself. This is the range that it's going to do a camera solve, and then it's going to extrapolate that construction. So it's very important the A and B, it's going to be doing all the heavy work between keyframe A and B. We'll have it automatically choose a good pair, and then tripod we leave disabled because this shot is moving in space. I'm holding my phone, which is what I'm recording it with, and walking. So it's not staying in one spot like a tripod would or a nodal pan. So we're not going to do any refining yet. I think we'll just do it as is. So solve camera motion. Hopefully we get something acceptable. Or maybe hopefully we don't. Yeah, we don't here. Here we get 145, so we can start talking about the troubleshooting process. And this is the frustration people usually have with the camera tracker. In Blender, it's very good, but sometimes you get these crazy errors where you shouldn't. So what we're going to do is we're opening up a graph here is what I'm doing, just so we can see. So you can see this blue, which represents our camera solve, is all over the place. Again, we want this to be perfectly flat. So before giving up and trying some different things, we need to make sure that we do a couple camera solves. If we always get 145, then we need to change something. So here we get 25, which is not acceptable, but you see it's not as disastrous as 145. I like to hit this button like 5 or 6 times, especially when I'm sure that these trackers aren't too bad. And then if we always get high numbers, we're going to just add some trackers. So right here we got 1.215, which is reasonable. That's a number that means, okay, it knows kind of what our camera's doing. And this, I kind of wish this happened in the first tutorial where we introduced camera tracking, but this is oftentimes the case. You have to hit this button a bunch of times, sometimes, to even get a acceptable solve error. But once we have this, we can actually begin refining. So we're going to turn off keyframe A and B. And then hopefully, if nothing changes, if we solve now, because we have these set, nothing should change. Yes, so we're now stuck on 1.215, and now all we can do is really improve this. So we can change or refine, so it tries to guess the focal length, the K1, K2, which is the barrel and fisheye distortions. Basically, it's lens distortion in 2 different types of concavity. You don't need to know about this, it's just guessing your lens distortion. And then we can also do optical center. Yeah, we can do optical center. Again, this is where the center of your footage is. Right now, it's guessing that it's right in the center of this frame, but this is depending on the curvature of the lens, whereas the kind of the center of it, if you were to blast a lot of light into it, and usually it's not a perfect cone down the middle, so we want to have it refined for all of these. We'll see if it actually does a good job at this. Okay, so we're now down to 0.78. Let's see what happens if we hit it again. Okay, so it's secure on 0.78, so now we're going to turn this off so it's not refining for anything. So if we hit this again, I guess it changed a little, but it's pretty much stuck on 0.7807, which is much better than 1.21. And again, now we can do some manual correction here. And the first thing I always recommended is looking over at these graphs and looking for anything that looks weird and maybe chopping it off. So for example, in this one right here, I'm wondering why this is diverging at the very end. So let's see. Okay, so this one kind of seems to make sense because it's very distant from the others. So it might have some different X behavior, which is what the red graph is. But we can always try trimming it off and see if it makes our solve error worse or better. So we can trim this off like this. Actually, we can't in this case. And the reason why is because this is a join track. So you see it blinks out of existence and then it comes back. So by clearing the right, we've actually cleared the second part of this tracking. And you can go manually and disable the frames, like specifically these frames, but I'm not going to mess with it. So that is one case where join tracks is actually troublesome. I wish there was a button to have a range where you can cut off frames. Hopefully that's a feature they can add, or I feel like that's a very easy add-on to make. Okay, let's see. For other behavior, that doesn't look good. Okay, this doesn't look too hot at the very end. It shouldn't be diverging that much at the very end. So let's try trimming this. It will either make it better or worse. So this made it better. So we went from 0.78 to 0.77 something. So that means it's something in the right direction. So you always want to do a tiny correction and then check if it made your thing better or worse. Okay, why is this so different? Okay, it's because it's way over there and it's pretty much separate from our other trackers, so that makes sense. And since most of our trackers were pretty good in this case, I'm not seeing too much divergence, but it will be usually very obvious. Like you'll have something shoot off where it doesn't make sense at all. But I'm thinking that other than this right here, which we could go in and correct, I'm thinking that this is all pretty good. So the next resort, I guess it's really the last resort, is changing our weight factors. Again, right now what it's doing is each one of these has its own error, which we can show with info. So each one of these is going to have an average error. So this one has 0.747, 0.454, which means it's better than the last one. And it's taking all those errors and combining them. So if we make the ones with high error worth less by bringing down the weight, it's not contributing as much to the solve. That is better for us. So it's a weighted average is what we're creating here. So I'm going to turn off lock. And I like turning off the video here so we can really see the text. I'm looking for the worst offenders. So here we have 1. Here we have 1.3. Yeah, 1.3 is probably the worst. So we take this one and bring down the weight halfway. See what else is doing not too hot. And by the way, when this text is red, it just means that the tracker isn't active right now. So this one probably comes in towards the end of the shot. Yeah, so then it turns yellow. So that's all that red means. We can take this 1.1, bring it down halfway. And maybe there was one more that wasn't too good. Yeah, this 1.037 isn't as bad as the others, so I'll bring it down to like 0.67. I'm not doing this very accurately. Let's do another solve, see if it helps. Okay, now we're in 0.59 territory, so let's do one more swipe or wipe, or I don't even know what those words mean, one more process of this, and then I think we'll call this good. So 0.8's not too good. What else? Yeah, 0.8. Bring this down even further. And it's pretty much expected that the one that was pretty bad was the one we edited before, because just by bringing down the factor, or the weight, doesn't make it a better tracker. So we expect this to still be pretty bad. Same with this one, we'll bring it down even lower. And 0.767, pretty much all the trackers we had to fix last time we're just fixing again. Okay, I'm pretty happy with that, so let's get 0.52. And we could try to go under 0.5. I'll do one more quick processing of this, bring down the weight even more. Or we can be a bit more drastic with this. What else is bad? This one's new. So bring it down just a little. See what that gives us. Okay, so now we're under 0.5 and I'm very happy with that. We can go down to 0.3, but you know, there's only so much you can do with a shorter tutorial. At least I expect this one to be shorter. We'll see about that. Okay, so if we look at our graph here, the blue line, which is representing our camera solve, is relatively flat. there are some hiccups, and you expect those hiccups to be where there's more motion. So around this area right here where our x-axis is moving all over the place, or our x motion really. But this is relatively good, so we can use this. So let's bring this over to the 3D viewport. And now we are done with the camera solving, and we're on to the process of bringing this into our 3D viewport with some orientation. So to do that, once we're happy with this, we just set up tracking scene, and now our camera will be moving when we play it. But like we talked about, this isn't going to be, it's not going to look like the plane's resting on the floor, and that's because these trackers, represented by these things that look like empties, but again, we can control it with our overlays, like that. They're not resting on the floor like they should be. We can fix this manually or automatically, which is what we're going to do first. So we're going to pick 3 of these to be on the floor, is the main attack for our orientation. So let's pick this one, and this one, and we can imagine the triangle that forms that we want this polygon to be on the floor. So let's set this to the floor, and now our camera moves so that our trackers, at least the relevant ones, are on the floor, and then the rest of these, like this one, is probably representing the wall. So let's play through this. Okay, so that's looking somewhat better. Still want to make some modifications. For example, everything's a bit too big, so picking 2 trackers, we can set scale, so that's 1 unit in between them. Let's make it so everything's smaller by making it 2 units in between them. Okay, that's looking a lot better. And for the rest of the stuff we can fix, we can make an origin. So right now it's resting on the floor, but there's no center point. So we'll pick this one to be our origin, and then there's no clear candidate for an X or Y axis relative to this origin, but if we just go along this line, this one's pretty close, so we can say that this is our, I guess, X-axis. It doesn't really matter. X-axis, that's looking pretty good. And now, if we're not happy with this, and I think we might be, the rest of the orientation stuff we can do is we're going to do manually. So going over to the side view, we want to make sure that these are resting on the floor. What is this one? This tracker should be on the floor, so it's not perfect. What about this view? Yes, this should definitely be on the floor. So what I'm going to do is with this camera, I'm going to lower it just a tiny bit and add a bit of rotation. There's only so much we can fix here. Okay, that's looking a bit better. And then in here, yes, these are a bit below the floor while these are directly on it. So we can rotate this way, assuming my camera is not inverted. So rotate, fix that a little. Okay, I think that should be much better. And then finally, yeah, okay. So in our camera view, finally, since this isn't perfectly the x-axis we wanted it to be along this line, we can just rotate, selecting our camera, R for rotate, and then Z. And this will rotate on the Z-axis, and we just want this red line, x-axis, to be parallel to the line we talked about, and then we can just redefine our origin. So that's G for moving the camera, and then along the green y-axis. Just bring that over. Okay. So now we can close this up and see what we have here. And it might be useful to actually include a timeline, just so we can see what frame we're on. By the way, animation nodes is installed for anybody interested in that. I'm starting a series. A little cross-promotion. Okay. Just want to make sure that this is sticking on fairly well and that there's no obvious errors. Yeah, so that's looking pretty good. And now we have this interesting case where we don't only have a floor, but we also have a wall, so we can reconstruct that geometry that's a bit more complicated than just a plane on the floor. So I don't need this cube, and for this plane, which should be set as a shadow catcher, I guess we can check by going into the rendered view and then into cycles, because Eevee doesn't have a shadow catcher right now. Yeah, so that is a shadow catcher, which hopefully they will fix soon because it doesn't work the way it used to. Again, we can go to film, enable transparency. Yeah, so that's a shadow catcher since we see transparency through it, but it's not actually lining up to our geometry. So we can move it, so G and then Y, and line it up against the wall. Just like that. And we can play through this to get a different angle. Yeah, that's still looking like it's in the correct position. And then in edit mode, we can select this edge and then extrude it upwards, like that. So now we have a shadow catcher that is, it's not just the floor, but it's also some more geometry. I had some kind of fly in front of my face. We can also make this go further out, the x-axis. And of course, this edge right here is way too far out. It's not even in the shot. So there we go. That's some geometry, and this is just going to be a shadow catcher. And to make this glitch out a little less, again, shadow catcher doesn't work the way it used to. We can go back to object mode, go over to the camera, and let's bring up this opacity of our background. So it's opaque. So alpha 1. Hopefully, yeah, that made it glitch out a little less since it's not trying to take these two transparencies and overlay them, where one is an opaque. Okay, perfect. So now if we add in an object, like a monkey, like we did last time, you can add in whatever you want. In the side view, we can make sure that is aligning correctly. Okay. So now, I'm rotating it so it's actually looking at us. So now we have this, but again, the shadow catcher isn't doing what it's supposed to do, which is to have its shadows, and that could be for many reasons. I think the one reason that this is happening is because of the foreground-background issue we talked about. Again, in the compositing, it automatically makes a foreground and a background. So going to the background layer, yes, so it separated it into the background layer. So we're just going to delete this layer and then move this from the background collection over into the foreground, and then delete the background collection. So now everything's in one. And then just to be extreme in this scenario, the shadows are not going to do what I'm about to do to the shadows isn't going to be very representative of the lighting of the scene, but I just want to show that the wall as a shadow catcher will also pick up some shadow. So here you have some shadow on the floor, and then it's going up the wall over here. We can make that even more extreme. Yeah, look at that. It's casting this giant shadow on the wall. Okay, that's looking good. We can even turn down the power of this light. Enable use nodes, make the emissive half. It's not as bright. And then for our size of the light, which is the intensity of the shadow, bring that up so it's a softer shadow. And we're not going to go over too much compositing again here, since we need to get to the tripod shot, but let's just quickly go over it. So once we're happy with this compositing, we no longer need this. Well, one of these was a background, so let's just get rid of one of these render layers. And we don't need this. So right now what we have is our footage, the image sequence being undistorted. Again, we calculated for lens distortion, so now it's getting rid of the distortion, so undistorted. And then this is just making sure it fits the frame. Don't worry about this one. We'll have this be the background. And then in the foreground, we're going to have our render layers, which is our monkey. So right now we have two undistorted node sequences. So here we have this undistorted footage, and then the render layers is just undistorted by default. It's just in our 3D viewport. So we have two undistorted things stacking on top of each other. And then to match everything together, we're just going to duplicate with Shift D and then redistort everything. So distort. So now everything's undistorted, and then you distort it back, and everything should be working. So this goes into the viewer, so that's what we see in the compositor. Going back to the first frame, of course we don't see our monkey because we haven't rendered it. So let's just make sure our settings are good. So in film, we have transparency. I'm gonna get a bit of water here. Okay, so we have transparency, and then for our samples, we're fine if it's grainy, we don't care, we just want to make sure that it works. So 2 samples, and then I think that's all we need because our color management is set to standard. Yep. And if you want to do filmic for the monkey, you're going to need to render it filmic and then have the background separate and then overlay them later as standard, but we're not going to worry about that. So if we hit F12, unless I made a mistake, let's see what we get. So we get our noisy monkey, and then it's going to add in the background, and everything is matching up. As you can see, if we go to another frame, where we're now here, let's render this frame, 93. Yep, so the monkey's a bit cut off, because that's where it would be spatially if we move the camera over there. So I'm going to call this a done shot. You know, you could put whatever you want in here, but this is just camera tracking, not messing around with your scene in 3D tutorial. So I'm happy with that. So I think let's do the tripod shot now. For the tripod shot, we're not going to do any of this monkey stuff, just the camera track itself and maybe a bit of orientation. So we can keep everything here, I think is fine. And then we're going to open up the movie clip editor and this time track the other image sequence. And this time let me get a big gulp of water so we can just, go through it. If you haven't made a tutorial yourself, or if you haven't done any public speaking for this song, you would be surprised at how fast your voice just goes, but we're gonna just, power through it. Okay, enough nonsense. What were we even talking about? We were talking about doing the other track, so let's open up the sequence on the desktop, tracking, camera track, and then finally the tripod sequence. Bring that in. And go back to the first frame. Now, a lot of the stuff is already set for us, like the frame rate is already 30. The color management, I don't know why this is open. The color management is already set to standard, so all that's good, otherwise you need to do it yourself. So again, set scene frames. Now we're going from 1 to 200, nice clean number. Prefetch, loaded into memory. Now, I've already emphasized this, but I just want to mention one more time. This is a tripod shot because I'm standing still. It's not really on a tripod, I'm just holding it in my hands and going like this, but it's in one stationary place and then just orbiting around. So, it's a different kind of solve, and really all we're going to be changing here is this checkbox right here. But the tracking process is pretty much the same. So I'm just looking for high contrast good trackers here. And I think a lot of these are going to blink in and out of existence since I move the camera around so much. But I do like this one right here. And tripod is actually, one of the good things about tripod is you don't really need to use that much affine or perspective. The reason why is there's no parallax change because we're just staying in one spot. So you wouldn't expect there to be any perspective differences. So really, you just want to use location, rotation, scale, which is what we talked about, is just tracking changes in translation, how the pattern rotates, and if it's getting closer or further away. And for this one, actually, there's no scale because nothing's getting closer. So we can actually do location rotation. So this is a case where you'd actually downgrade your motion model because it makes sense and it saves you time. We can still enable normalize. There could still be lighting changes. And then correlation, I still want to stick to 0.9. So location, rotation, motion model. Let's see how it does. Put a tracker here. Go to the tracking window so we can actually see what's going on here. Alt-S for the search box. And this one I'd imagine is going to be even faster than the last one, but we'll see. Control-T. So made it up till here. I think we can get an extra frame out of this. Okay, so I'm happy with that, and we'll see if it comes back in so we can do a join track. I suspect that it will. Yeah, there it is. But does it last long enough? Yeah, it does. So it's worth actually doing. If it was only there for like 3 or 4 frames, I don't know if I would have. Although objectively it is what you want to do. So make sure it's the same dot. Let's track backwards a little. And then forwards with Control-T. Control-L to lock this. And this time I'm going to really try to do this at full speed to show you how fast you can do this. So track, join track. It's going to make the commentary a bit harder, but I think it's worth it. So let's pick something in the brick here, something that looks unique, like this one that has this protruding brick. Control-T. Add another reference frame since it blinked out, and just keep adding reference frames. It does seem like there's a bit of parallax change. Again, I'm not holding it on a tripod really, it's just in my hand, so there's supposed to be a tiny bit of parallax change, which I think is what we're seeing here. Otherwise, there wouldn't really be if it's perfectly stationary. But I'm fine doing it this way. Let's lock that in, and I do want to review this one over here, just making sure the center point is relatively in the same area. Yeah, everything kind of looks a bit wobbly, but that is staying in the center, so that's good. And this time we're going to use affine to get rid of that issue. Let's do this right here. Track forwards. Now you're seeing tracking at speed. Let's get a couple extra frames, lock this in, see if it comes back. It does. actually never even blinks out in the first place. We just have some margin issues. So I'm going to unlock this and then scale it down. Just get those extra frames. And then once we're in the safety area, we can scale back up and lock that in. Let's try to get one more in this area since it seems to be in frame the whole shot. So with Affine, let's do one here. Again, we don't need to really pick dots or anything, just anything with a recognizable pattern that you could track with your eyes and doesn't have any reflections or it's not moving like a biker or a leaf over here you wouldn't want to do necessarily. It's always good to pick some stuff with some distribution in 3D, so let's pick something in the background, like the corner of this vent, like that, and track that. We can get an extra frame here. Maybe not, we'll just lock it and see if it comes back. I kind of doubt it since I angle the camera down. Yeah, so that one's done. What else is in the background? If we pick this, it shouldn't... Yeah, there shouldn't be any parallax. So normally this box right here would kind of obscure it after a while after we move the camera, but since there isn't that much parallax, this will always be visible. So let's add a tracker here with this dark brick. Control T. And especially on tripod shots, it's really important to get a bunch of different depths and get that 2D and 3D distribution we've been talking about. We can actually use a lot of these squares that seem to be everywhere. That will make very obvious tracker markers. Will take a bit longer, but it is a good candidate. Lock that in. And we should be getting pretty close to having 8 throughout the whole shot. I'm going to go for another one of these like this one. This is great for tracking because we have these 2 lines like this that make it very clearly defined what we're tracking. So that only lasts for 60 frames. And it should come back. We'll see. Okay, it does. So I think it was down and then 2 to the right. Let's see, yeah. Down, 2 to the right. So wait for that to pop up. And then add this in. Again, make sure you're not selecting the wrong tile. Otherwise, your solve will always be like 150 every time you hit camera solve. Track backwards. And then go to where this ended off and track forwards. Again, we're doing this at speed. Lock that in. Go back to where it was visible. Shift click and join. Okay, let's see. Let's go to the last frame and see what else we can pick up here. I wonder if this twig is here for the entire shot. That might be a good tracker. Assuming that it's not moving in the wind or anything. We'll see about that. Yeah, I think it's staying on there. Okay, so we'll lock that in. That made it pretty far. What else? I'm looking for tiny dots now because they are very easy. We'll see if the motion blur is an issue for this one. It's already very hard to see. Nope, that worked out perfectly. Maybe we'll keep testing our luck on these. See this tiny white dot in the background? We'll pick that. You get pretty good at detecting what would be a good tracker marker as you do more and more of this. So if you're like, oh, how did you see that? You're going to notice it when you're desperate and need that camera solve. You'll see it. I'm in the hot seat, so let's see, what else? Let's get some stuff in the background here. These bricks, at least some of them are looking very distinct. Track backwards. You know, one issue I'm noticing, we'll see, does this even come back? Yeah, one issue I'm noticing is a lot of these trackers aren't surviving the whole shot. I'm going to delete this one. And it's not a big deal, but it is nice to have trackers that last a long time. And also, we have nothing on the right side over here. So that's not very good for our 2D distribution. So let's add something in a spot we can pick out again. So like that. Track forwards. Okay, made it to frame 59. Let's see if it comes back. So it's this very discolored brick, the bottom right corner of that. Okay, so that is coming back. Can we pick it out? I think it was this. We'll make sure to check again. So track forwards, and then track backwards. Lock that in. So I want to make sure that it's the same one. So we have this discolored brick that's at the same height as this piece of the wood over here. So let's see if that's the same. That appears to be the same. So we can shift click, join tracks, and do we have 8? I would believe it if we don't. So I'm just going to pick one more of these tile trackers, maybe this one, because they seem to be plentiful and pretty much a free tracker marker. And a lot of them do seem to last the whole shot. My last bit of water. This is going to be precious. Very precious. Come on, make it through the whole shot. Do it. Oh, look at that. It almost didn't make it, but it's a survivor. Look at that. It was really on the margin. Okay, let's lock that in. And then we'll try to do a solve. It will tell us if we don't have 8 active trackers. There'll be an error message right here. I don't think we've ever ran into this issue, but maybe we'll see the error message for the first time. So hopefully that goes away in a second. So solve. And then this time make sure to enable tripod. And then relatively everything is the same. You see a lot of this keyframe stuff is grayed out. We're not going to worry about that. So with tripod enabled, let's go for a camera solve. Okay, 3.76. With tripod shots, it's a bit different in that it's kind of okay to have a bit of a higher solve error, but really what's really telling is the graph. We want to tell the quality, we want to look at the quality of our graph. Okay, so this is like, it seems to be capturing our camera motion, just not very well. Let's go for a couple more solves. Yeah, so that's consistent. And I wonder if the keyframe settings even matter with tripod. They might not. Yeah, it seems that they don't. And there's probably some theory behind that, because when it's doing its limited construction and then extrapolating, that's dependent on looking at a set of trackers between the frames and looking at how they move in terms of parallax. And when that doesn't exist because of tripod shots, it no longer becomes relevant. So it's okay to have a bit of a higher solve error here, but ideally we want to minimize it. So with refine, we'll refine for everything. See how that does? Okay, now we're down to 2. And this graph is looking a bit more settled. Let's go for 1 or 2 more. See if it's constant. Sometimes what happens here is it will actually change the focal length and the optical center that it's going for. Yeah, you see it's doing tiny adjustments over here. So sometimes it gets something a lot better, or sometimes it gets something a lot worse, but after a while it tends to stabilize on this number apparently. Again, it's okay to have something a bit higher here, but we can do the same tricks as always. See if we have any inconsistencies with our graph. Make that a bit bigger. So these dips over here just mean that they just came into existence. You see this tracker right here. So it's going from 0 to whatever value. So this isn't actually an inconsistency, but maybe the beginning of this is. So let's try trimming and doing a solve without any refining anymore, just so we can see if this changes anything. Is that worse? Okay, yeah, that's worse, so you want to undo that. And you just want to try this and see if it does better or worse. So let's go for this one. Trim the end, solve. That is better. Okay, so that's a case where it actually helped us. And I'm expecting to find 1 or 2 more of these. Yeah, what's up with this one over here? Is it because it's a weird tracker? It might be because it's going to the margin over here. But I'm going to cut this off and see what happens. So trim. That actually worked. So let's go even a bit further. Trim. Okay. I'm happy with that. And let's see if we can do any more correction before messing around with our weights. I think we just messed with this one and we ran into an issue. So let's not do that. Okay. So if you look into this, you might be able to do a bit more, maybe with this tracker specifically. Let's try one more round. Trim. I think that helped. I don't even remember what number it was. But let's say that we're actually done with this step, and then we're on to the last step, which is the weights, which makes really bad trackers worth a lot less. We've already gone over this, so turn off the footage, info, so we can see all the errors. And whoo, yeah, some of these are really bad. Some of these are 3.2. Whereas some of these are any of these under 1? Yeah, this one's 0.8. So we can do a lot of work here with the weights, more so than with a normal parallax shot. So let's actually do that. So with this one, we want to cut down the weight to half. And with anything that's like 3 point something, that's really bad. Cut down the weight. What else do we got? 3.38. Sounds good to me. Not good as in a good tracker, but good to cut down. And then you want to disable this lock so we can zoom in closer. Okay, a lot of these seem to be doing very well. Did we handle this one? Okay, so let's go for a solve. Okay, now we're in 1.6, so getting even better. And let's just do 1 or 2 more rounds of correction until we get down to like 1.3, I think I'd be happy with. And again, the camera solve kind of matters less because you're just going to get a camera that's moving around, so it's not going to look like things are sliding around as much if you have a half-decent solve. What else is doing not too hot? This 2.4 is pretty bad. Let's go for another solve. Okay, 1.46. I did say 1.3. We'll see if I hold on to that promise. Might not. This one we need to cut down a lot. And it's just this refining process. I think there is a script that I saw somewhere that does this automatically, but I think it usually goes a bit too far where all these weights turn to like around 0, which isn't very good because now you're not representing the shot, the original shot that well, and you want to retain some of that motion data. So you don't want to get too extreme with this. Okay, we're under 1.3, I'm happy. If we look at our blue line, there's a bit of inconsistency, but it's relatively flat. So the interesting thing here is actually doing our orientation. So with our 3D viewport, oh yeah, we have all this set up. So let's actually get rid of all this, I guess, and add in a new camera. And it doesn't really matter where it is, it's gonna do the camera solve no matter where the camera is, it's independent of location. Yeah, so once we're happy with the solve, we can set up tracking scene. And you see that this one's a bit different. If we play this, the camera's staying still, but it's rotating around its location. If we hit N for properties, we can see that this location is staying still. So that's the important part here. And in terms of orientation, we're kind of missing the most important part here. So I want to make sure we actually see this. In terms of orientation, or in terms of these trackers really, you're going to notice that they're all at the same distance from the camera. It's actually creating a sphere around it, and it's projecting those points on the sphere. So all of these exist on a sphere of a certain radius around the camera, which means that it doesn't really know the location of our trackers, and it shouldn't because it doesn't have any parallax data. So that's what makes a tripod shot very special, in that these trackers don't really mean much in terms of their location. Because even if one's very far out and one's very close, it's going to project them to the same distance, since it just doesn't know with the information that's given. Now, that doesn't mean we can't do a bit with orientation, so we can still pick a, initial position and orientation for this, but it's just that it doesn't really matter where these are. So there's no like origin, floor plane, or anything like that. But if we go into this, you see that this is sticking on very well, just in a very different way. So let's move this to a place that makes more sense, like over here. Play that out. Yep, that is tracking on very well. Move this down a little. And you want to do this orientation manually, I would recommend. So it's kind of hard to tell. But we're going to set this rotation to make sense on this frame, and then it's going to move around. Top view might help here. So what I'm doing is I'm just setting this camera to look straight ahead on whatever frame we're on, frame 199, essentially the last frame 200, and then it's going to move around based off that, which will make our plane kind of look like it's resting on the floor. Of course, we still have the issue that it's looking like it's angled downwards, and to fix that, we want this view. We need to rotate until it's looking right. It might be even better to do this in the camera view. So rotate on the y-axis until this is lining up. And then if we play through this, you can tell that the solve error, even though it's higher than what we usually accept, it's not as significant. No matter what you put, no matter where you put it in the scene, even if we move this cube here, it's going to look like it's really attached to our frame. And in terms of compositing, it's pretty much the same deal as always. We have this background, and it made a background layer for us. And if you want to mess around with the shadow catcher, you want to move everything to the same layer. And it might have even messed with our compositing. No, it didn't. It actually kept it as is. But it's the same type of deal. It's just that this time, we don't have any parallax. So my voice is officially gone now, but we've done it. We've gone through part 4 of the motion tracking tutorial series, and very soon, oh, could you hear that? Did that hurt to hear? Very soon, we're going to be doing object tracking, which I know is what everybody's getting hyped about. So that's the next part in this motion tracking series. So I hope you guys enjoyed this. I know it was more of a repetitious type tutorial than what you're used to, but I do think it's important to go through these examples. So from now on, whenever we're doing our camera solves or object solves, which are going to happen to be very similar, you're going to know how to do it at speed. So my voice is gone. I'm probably croaking at this point, so I think I need to go. Check out Patreon if you want to invest. Put your money into these tutorials. For example, this microphone. That should hopefully sound better. Not my voice, but this microphone sounds better. This was due to Patreon investment, so it goes directly into this channel. I think that's all I have to say. My voice is gone. I'm out of here. I'll see you on the next one. Bye-bye.